We are going to take a look at functions today. A function is a set of ordered pairs in which each value in the domain is paired with exactly one value in the range. So what that means is that x cannot repeat. And that is a very important piece of information there. So if it's a function, the x value cannot repeat. So make sure you write that down for your notes today. The domain is all of the x values, and let's just say we had these ordered pairs here. Just give an example. Our domain is all of the x values, so I would write the domain like this. We listed out 2, 4, and 6. And that's easy as that if they ask you what the domain is. If the question says what is the range, you put the R out front, the colon, and then the brackets, and you list your Y values, 3, 5, and 7. If the Y values repeat or the X values repeat, well, the X can't repeat because it's not a function, but if the Y values repeat, you only need to write them once. So if, let's say this 7 here was a 5 as well, then I would only have this for my range, 3 and 5. We don't need to write 3, 5, 5. It's already included. Okay, so for example 1, it says a fundraising program awards $30 for first place, $20 for second place, 10 for third, and 5 for fourth. This function can be written as these ordered pairs. Express this function as a table, a graph, and a mapping diagram. So the first thing is a table, and that is just a T-chart where you have your X and your Y values. So we have 1 and 30, 2 and 20, 3 and 10, and 4 and 5. Next is a graph. And they are all positive points. So I'm just going to draw quadrant 1. So 1, 2, 3, and 4 for our x values on our x-axis. And then we need to go up to 30 on our y values. So 10, 20, 30 by tens. And then plot our points. Over 1 up 30. Over 2 up 20, over 3 up 10, and over 4 and up 5. And then last, for our mapping diagram. Mapping diagram is very similar to the table, except for it has 2 different bubbles. A bubble for the x, and then a bubble for the y value. So 1, 2, 3, and 4 for the x's. And I'm going to put them in order, 5, 10, 20, and 30. And then you match up. 1 goes with 30, so an arrow to 30. 2 goes with 20. 3 goes with 10, and 4 goes with 5. So that's a mapping diagram. The domain of the function in example 1 is 1, 2, 3, and 4. What is the range? Well, it's easiest to figure out the range off of using the table or the mapping diagram. But remember, I said we put an R, and then we put brackets, and then we list them in order. So 5, 10, 20, and 30. And that's all there is for the range. Then this little blurb here, f of x equals 2x plus 5 is the same thing as y equals 2x plus 5. So the function of x, that's how that's read. The function of x is the same thing, f of x is the same thing as y. So up until now, you've been using y equals for your equations. Now, if it's a function, it's going to be f of x. It could be g of x, it could be c of t, it could be anything. The f just simply names the function, just like you guys have names, and they're different. So the functions would have different names. And then the letter that's inside of the parentheses is the letters that being used for the variable in the actual equation, or in the over here on the right hand side. So let's say I did g of m, then I would have to write 2m plus 5. So whatever's here in the parentheses is the same letter that's over here. All right, so for example 2, the number of dollars Julio earns while working X hours can be represented by the function f of x equals 9x. Graph this function. So let's pick some ordered pairs, some x values to plug in here. X represents the number of hours he's working. So I don't think that you want to use negative numbers. It wouldn't make sense to work -5 hours. So we're going to pick some positive numbers. So I'm going to pick 0, 2, and 4. And then if I plug those in, 9 times 0 would be 0, 9 times 2 is 18, and 9 times 4 is 36. And we have to graph those. So again, all positive. So we're just going to use the first quadrant. And I went up to 4 for my x values. And then I have to go up to 36 for my y values. So I think probably going to try for 10s again. So 0, 0 is an ordered pair, so a point goes there. Over 2 and up 18, about there. And then over 4 and up 36, somewhere in there. And would it make sense for him to get paid for working other hours other than the positive even number hours? He definitely could work 1 hour. He definitely could work 9.5 hours. So yes, it would make sense to connect these because he's going to get paid based on the number of hours he works, not just every 2 hours. All right, example 3. Given the functions f of x equals 3x plus 2 and g of x equals -x plus 10, find the value of x for which f of x equals g of x. So in other words, when are they equal? So there's 3 different ways we can do this. And the first one is set the rules equal to each other and solve the equation. So I'm going to write 3x plus 2 is equal to -x plus 10. And then I have to solve for x to figure out when they are equal. So I have an x on both sides. I have 3 on the left and -1 on the right. So I'm going to add x because that's the smallest one. So I'm going to have 4x plus 2, and the x's cancel, and I just have 10. Then I'm going to minus 2 from both sides, and I'm going to have 4x here. 10 minus 2 is 8. And one more step. Oops. We're going to divide both sides by 4. So x equals 8 divided by 4 would be 2. So what would be x when both equations are equal? X is 2. So now for method 2, we're going to create tables to find the value of x where the functions have the same value. So whenever you're asked to create a table and they're not giving you the x values, you're always wanting to use -2, -1, 0, 1, and 2. That way it gives you an idea of where they sit, -0, and then some positive numbers. So it's a good mixture of both types of numbers. So again, we want to use these numbers when they don't tell us what to use for x. So for the first one, 3x plus 2, 3 times -2 is -6. -6 plus 2 would be -4. 3 times -1 would be -3. Plus 2 would be -1. 0 times 3 is 0. Plus 2, would be 2. 3 times 1 is 3. Plus 2 is 5. 3 times 2 is 6. Plus 2 is 8. And then over here, g of x, we have -x plus 10. So if our x is already negative, we're plugging in a negative. We already have a negative there, so 2 negatives is going to make a positive. So for the first one, -2, it would actually be 2 plus 10. So that's going to be 12. -1 would be 1 plus 10. That's 11. 0 plus 10 is 10. -1 now, since I'm plugging in a positive, -1 plus 10 would be 9. And -2 plus 10 would be 8. So we are looking for where they are the exact same. And what I notice is right here, we have 2, 8 as an ordered pair, and we also have that over here as an ordered pair. And then method 3 is to graph both functions and find where they intersect. So we're going to graph both of them on the same coordinate plane. And remember the form mx plus b that we learned about last year. B is our y-intercept, so that number at the end in the first case is a +2. That's going to be our y-intercept. So on the y-axis, I can put a dot at +2. And then the number in front of x, which is our m, is our slope. And that tells us our rise over run. But if it's not a fraction, we're going to make it a fraction. So we're going to put a 1 under it. So my slope is 3 over 1. So I'm going to go rise 3 from this dot I just plotted. So up 3, and then I have to go over 1. And I'm going to connect that line. And then for the other one, my y-intercept is a +10, which is way up here. 2, 3, 4, 5, 6, 7, 8, 9, 10. So up here, we're going to have a dot. And then my slope is -1 because that negative sign is really like a -1 there. So if I make that into a fraction, my rise over run would be -1, 1. So that negative means go down and then over 1. And because I hand drew this graph, it's not entirely perfect. But from the other two methods, we do know that they cross at 2, 8. So here's 2. I was a little bit over there, but there is the ordered pair at which they cross. If you're given a problem like this in your homework, there will be a coordinate plane already given to you so that your graph is going to be much neater and you'll be able to see exactly where they cross.